Hello everyone, I Deepika Singh, final year student of BTech Civil Engineering from Faculty of Engineering and Technology, University of Lucknow. I here to present my topic for seminar presentation. My topic is high performance of building for cold climate. Following is a table of content in the flow of presentation which basically include introduction, and after that I compare between normal building and high performance building for cold climate, and then I will tell essential features in designing of a house cold climate and recommendations and some popular studies and references. Now move to next slide. I would like to present with introduction. Reason that fall under the cold climate experience very cold winter as they are at a very high altitude. State such as Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Arunachal Pradesh, Sikkim and north part of UP have a cold climate. The temperature range between 20 to 30 degrees Celsius in summer days, while in winters it can range from -3 degree to 8 degrees Celsius, make it quite chilly. The building in such region need to be properly insulated so that the internal heat is retained with minimum losses to the environment. Now the cold climate can be further divided two categories. First, cold and sunny and cold and cloudy, and this map is indicate the climate zone of India. It is based on the climatic condition of different region of the country. It has been divided into a 5 climatic zones. Switch to next slide. Now I'll explain cold and sunny and cold and cloudy. In the cold and sunny type of climate is experienced in Leh Ladakh, but the cold and cloudy type of the climate experienced in Shimla, Shillong, Srinagar, Mahabaleshwar. In the cold and sunny, the solar radiation is generally intense with a very low percentage of diffusion radiation, but in the cold and cloudy, intensity of solar radiation is low with a high percentage of diffusion radiations. In cold and sunny, in the summer, the temperature reaches 17 degrees Celsius to 24 degrees Celsius during the day and 4 degrees Celsius to 11 degrees Celsius at night. But in the cold and cloudy in summer days, the maximum ambient temperature in the range of 20 degrees Celsius to 30 degrees Celsius during the day and 17 degrees Celsius to 27 degrees Celsius at night, making summer pleasant. Under the cold and sunny, in winter, the value range from 7 degrees Celsius to 8 degrees Celsius during the day and -14 degrees Celsius to 0 degrees Celsius at the night. But in cold and cloudy, in winter time, the values range between 4 degrees Celsius to 8 degrees Celsius during the daytime and -3 degrees Celsius to 4 degrees Celsius at the night times. Under the cold and sunny, relative humidity of consistently low ranging from about 10 to 50%, and precipitation is generally less than 200 mm per year. But in cold and cloudy, relative humidity is generally high and range from 70 to 80%, and annual total precipitation is 1000 mm, and it distributed evenly throughout the year. But in cold and sunny, the sky is fairly clear throughout the year with a cloud cover of less than 50%. Under the cold and cloudy, sky is overcast for most part of the year except during the brief summer. Now switch to next slide. I'll discuss difference between normal building and cold climate building construction. Under the normal building construction, insulation standard moderate thermal resistance, and window used is single panels or poor insulation, and ventilation basic poor air quality, and thermal bridging is significant heat losses, and moisture control is prone to condensation. Roof design can be flatter and focus more on aesthetic and drainage, and material concrete, brick, stone, and insulations are used. Under the high performance building cold climate, insulation advanced high thermal resistance and window double triple glazed used. Ventilation efficient with heat recovery and minimize for less heated use the thermal bridging and superior management no more to moisture control. Roof design is a steeper roof as preferred to prevent the snow accumulation. Material insulated structure, insulative panels, brick and stone, etc. Essential features in designing for cold climate building. First one is building should have slope roof, and second one is window should have wooden panels, and third one is timber panel wall we used instead of brick and stone masonry, and bedroom will be on the southwest of the house, and next one is kitchen will be on the southeast of the house, and flooring of the house must be on timber, and tree can be planted near the window for block of cold air. Now recommendation for high performance of building for cold climate. First one is site. Landform building should be located on the south slope of hill for better access to solar radiation. And second one is open space and building form. Building should be clustered together, and in cold climate street orientation should be east to west to allow the maximum south sun to enter the building. The street should be wide enough to ensure the building on one side do not shed those on the other side, shown in the figure. Next one is orientation and plane form. Building must be compacted with small surfaces to volume ratio to reduce heat losses, and should face south facility direct to gain the solar radiations, and north side of the building should be well insulated. Living area can be located on south side, and airlock lobbies at the entrance small surfaces to volume ratio to reduce heat losses, and should face south facility direct to gain the solar radiations, and north side of the building should be well insulated. Living area can be located on south side, and airlock lobbies at the entrance and exit point of the building reduce heat losses. Next one is building envelopes. First is roof. False ceiling with internal insulation such as a polythene foam, thermocol, wood wall, etc. Next is aluminum foil is generally used between the insulation a layer and the roof to reduce heat losses to the exterior. The sufficient sloping roof enable quick drainage of rainwater and snow. Skylight on the roof admit heat as well as light in winter. Next is wall. Wall constructed with double stud frame and should be made of material that lost heat slowly and should be also insulated. The south facing wall could be high thermal capacity to store daytime heat for later used. Move to next slide. Moving on to case study. First case study, residential building in Leh Ladakh, India. Leh, located in northernmost region of the India, is the main town of Ladakh. The region is known for its harsh climate, high altitude, and unique cultural heritages. Designing residential building in the area present a number of challenges due to extreme weather conditions. And the object of this case study, design a high performance building that provide thermal comfort, reduce energy consumption, and minimize environmental impact in the extreme cold climate Leh Ladakh. And the key challenges of the cold climate building: sourcing high performance material in remote areas, and construction techniques, implement advanced construction techniques in region with limited resources. The next one is design strategies. First, insulation. The building use super insulated material in its envelope, including triple glazed windows and high insulated wall and roofs that minimize the heat losses. Next one is window design. Install double glazed window with e-coating to reduce heat transfer and minimize cold air infiltration. Passive solar design for cold climate focuses on maximizing solar gain to heat a building during the winter months, and while minimizing heat loss and reducing the reliance on mechanical heating system. Next is thermal mass. Incorporated thermal mass element, example concrete wall, brick floor, absorb and release heat regulating indoor temperature. And next is air tightness. Ensure a tight building envelope to prevent cold air infiltration and reduce heat losses. Now move to next slide, performance. Study reduce energy consumption by 50% compared to the traditional building in the region and maintain indoor temperature ranges 18 to 20 degrees Celsius during the coldest month and reduce carbon emission by 70% compared to traditional building. Next is lesson learned. First is contextual designing. Designing building that responds to the local climate and culture and choose material that balance performance, cost and ability. Involve local communities in the design and construction process to ensure acceptance and long-term maintenance. Next slide, some references are available. Thank you.